In this problem, we're going to use the graph of a function to discuss the continuity of the function at various points. We'd like to determine whether f of x is continuous at each of the following points. If it is not continuous, we want to explain why it's not continuous. The points we're interested in examining are x equal to negative 2, x equal to 1, x equal to 3, and x equal to 4. In order for a function to be continuous at a point, recall we need the limit as x approaches c from the left to equal the limit as x approaches c from the right. And that has to equal f of c. So the two one-sided limits must exist and be the same and also be equivalent to the value of the function at that point. If we look at x equal to negative 2, when x is negative 2, we see a hole in the graph. It means the function is not defined there. So the function cannot be continuous at negative 2. Move on to x equal to 1. If we look at x equal to 1, we see the function is defined. This point indicates the function is defined there. And we notice that the limit from the left is 2. The limit from the right is also 2. But those do not equal the value of the function at x equal to 1. So the function is not continuous at x equal to 1. For x equal to 3, we see the function is defined at x equal to 3. The limit from the left is equal to 5, but the limit from the right is equal to negative 3. Since the limit from the left and the limit from the right are not equal, as we require, we'll say the function is not continuous at x equal to 3. In our last point, x equal to 4, we look and see that the that the function is defined at x equal to 4. As we approach x equal to 4 from the left, we see the value of the function looks to be about negative 4. As we approach 4 from the right, we get that same value for the limit is negative 4. So our limit from the left is equal to our limit from the right. It's equal to the function value. And so we'll say that the graph is continuous at x equal to 4. So it's not continuous at negative 2, 1, or 3, but it is continuous at 4.